So these are your rules for integrating. Again, page 26 of your log tables. Okay, so to integrate cos of x dx, that's sine of x. Okay, to integrate cos of ax, which would be 2x or 3x, you're dividing by whatever the a is, so sine ax over a. So, example 1, find cos 4x dx. So integrate cos 4x dx. What's that going to be? Sine 4x over 4 plus c. And what about this one? Integrate sine 3x dx. So you're down here, it's going to be minus cos 3x over 3 plus c. Is that okay? Can I get rid of the board? Okay. Okay. Example 2. If y is sine of 3x squared, find dy dx. So it's another scenario where they're giving me the function and they want me to integrate it and then use my answer. Okay, hence find the integral of this. Okay, y is sine of 3x squared. What would dy dx be? How do I differentiate this? Differentiate sine, you get cos. Okay, so it's going to be cos of 3x squared multiplied by the derivative of this exactly. Differentiate 3x squared? 6x. Okay, so you get 6x cos 3x squared. Now, it then says, hence find the integral of 6x cos 3x squared. Where have I seen that before? Right there. When I integrate that, where do I get back to?
Y.
The y, yeah. Okay, so integrating 6x cos 3x squared dx, when I integrate my derivative, I get back to my function plus c. Is that okay? Can I get rid of the board? Okay, example 3. Okay, so let h of x equal x ln x. Find the derivative of h of x. Okay. Now, x ln x, go back to your calculus. What's happening here? It's product rule. Two things being multiplied and they both have x. It's product rule. So it's u times dv dx plus v times du dx. Do you remember that? Okay, so it's u times dv dx. So ln x, when you're differentiating ln x, you get 1 over x. So it's u times dv dx plus v times du dx. Differentiate the x? 1. Okay, so just note to yourself. That's what's happening there. So the derivative of that is 1 plus ln. Now, part 2 says, hence find the integral of ln x. When I integrate that, what do I get? If I was to integrate the derivative, I would get back to the function. Okay? So if I integrate this, I'm getting back here. So let's write that down. Integrate 1 plus ln x I know I will need to fill in a plus.
Why is it ln x? Is it not supposed to be x ln or?
Where are you? Here?
Hence find above. Yeah, is it not supposed to be? Is it?
It's the integral of ln x. They haven't actually asked me for the exact thing I gave them here, so we need to manipulate this to make it look like this. Okay, this is slightly different to the other questions. The other questions, I just had to write down my function. But in this case, I know that when I integrate this, I get back to my function, and I'm going to manipulate this a little bit to make it look like the question. Okay? Okay, now, I'm not interested in the integral of 1 plus ln x. What I'm actually interested in is the integral of ln x. Okay? So, I know when I'm adding two things underneath the integral sign, I can just integrate both of them separately. Okay, I do know I'm going to have to put a plus c in at the end, I'm just not doing it yet. Now, is everyone clear with what I've done here? I've taken my answer from part 1, okay, which was the derivative. And I know when I integrate the derivative, I get the function. So that's all I did. I wrote the integral of that gives me the function. Now here, integrating these two, I'm just integrating them separately. The question is, find the integral of ln x. So I'm only interested in this part, aren't I? Okay, so the integral of ln x dx. Where is that integral going to go? Over here and become a minus. Okay? So the integral of ln x dx is, nothing happens there. Integrate 1. Increase the power by 1. Yeah. So x to the power of 0 becomes x to the power of 1. Okay? Plus c. This is an example of one where I needed to use my answer, integrate the derivative and put it equal to the function, and then just move things around so that you actually get what the question is asking. Okay, in all the other questions, they wanted us to integrate this, and we know it's just our function, but in this one, they only wanted part of it, so we needed to move things around.